Hello and welcome to this session of blockchain. Myself, Saurabh, and I'm part of the Simplilearn team. So let's get started to understand what is blockchain. What's in it for you today? Let's discuss what are the issues with today's current banking system, how Bitcoin has solved these issues, and how Bitcoin is evolving. What is blockchain technology and what are its features like public distributed ledger, how encryption works, proof of work, algorithm, and mining, and we will also discuss certain use cases of blockchain mining. Now, what are the current set of issues in today's banking system? In order to do any transaction on a banking channel today, it costs a very high transaction fees. So suppose you want to do a transfer of money from your account to someone else's account through a banking channel, the bank might charge a fee for a $200 transaction up to $5, and the receiver will end up receiving $195, which in percentage terms is a very high percentage of transaction fee. Also, as of today, there's a lot of scenarios people end up doing double spending. For example, over here, the user has $800 in her account, but she ends up sending $1,000, $500 each to two users. Double spending is a unique problem where digital money is spent twice. So what does it tend to do is the user is able to make two purchases with the amount which is less than the purchase value. So in this scenario, the lady was able to buy a commodity worth more than $800, though she only had $800 in her account. Also, the banking systems are prone to hacking. Hackers attack financial institutions and gain unauthorized access to data. They can do transactions on your behalf which you are not aware of, or they can do the transfer of money to some illegitimate accounts. In 2017, the number of frauds in India through ATM cards and net banking totaled to 1,785, each amounting to more than 1 lakh rupee. So if you see, the current banking system is prone to so many hacks that it can amount to huge cost of money. Now, how Bitcoin can solve these problems? Now, Bitcoin is a decentralized system, so which allows you to do a value transfer transaction at a lower transaction fee, as low as $1 as compared to the $5 which the bank was charging. And at the end, the receiver receives the true value of the amount which was sent by the sender. Bitcoin follows a decentralized system where no third party like governments, banks, or any other financial intermediary is involved during the transaction between the sender and receiver, thereby reducing the cost of transaction drastically. And that is the primary objective of cryptocurrencies or technologies like blockchain, which advocates the removal of intermediaries. Now, Bitcoin is a cryptocurrency that runs on blockchain. Now, how Bitcoin solved the problem of double spending? Double spending is avoided through the basic structure of blockchain, which involves verification of transactions. So in the previous example, as we saw, when the user transferred $500 to the first person, then she will not be able to transfer the another $500 based on the basic validation of the blockchain, and we will see how. So suppose you're trying to spend the same Bitcoin in a second transaction. After the first transaction has been confirmed, the second transaction will not get verified and thus become invalid. And this will happen because after the first transaction has been confirmed, your balance will be verified in the second transaction, your address identity will be validated, and if suppose you're trying to spend more than what the balance you have, the miners, the validators of the blockchain network will discard that particular transaction and will not add it to the main blockchain network. Thereby, double spending becomes as good as impossible. In a blockchain, each block is linked to its previous block. The transactions become invalid for a specific Bitcoin which has already been spent. So you can't spend the Bitcoin which you have already spent. Public ledger. A public ledger records all Bitcoin transactions where it is accessible to everyone who is associated with the system. It is a 100% transparent system. Any transaction happening is visible on the public ledger. Once a user joins the blockchain network, he gets a copy copy of all the blockchain transactions since its initiation or inception. And the first block in a blockchain is called the Genesis block. Though the public ledger is accessible to everyone, only the user's address and the transaction details are visible to the users on the Bitcoin network. By looking at the address, you can't figure out to whom this address belongs. The identity is secure of the address owner. This keeps blockchain safe from data tampering. Each block on the blockchain is aware of who is its previous block, and this way the entire blockchain is created. Even if a hacker tries to hack one block, it would have to change the entire subsequent chain ahead of this block, which will require huge amount of computation power for the hacker in order to make the changes across all the blocks, which is next to impossible. Now, what is blockchain? Imagine two friends living far away and would like to transfer money using blockchain technology. Blockchain is a decentralized system of secure and trusted distributed databases. It's a distributed ledger which records and shares the transaction details across many nodes which are part of the network so that the data is not modified. So each and every transaction which happens on a blockchain network is distributed across all the nodes on the blockchain. Each and every participant has the same copy of the ledger, and it's an immutable ledger. Once a record or a transaction is registered, it cannot be modified. Blockchain was originally introduced to timestamp digital documents and prevent tampering of records. In simple terms, a chain of blocks that contain information is called blockchain. Now, when a transaction occurs, its related information is recorded into a block. So as you see, a transaction initiated in one corner of the globe can get registered on the block, and then that block is being verified, validated by the miners of the public ledger, and then added to the main blockchain. A block contains aggregated transactions in a single block which a miner has to validate, and in lieu of that, the miner gets rewarded. Now let's take a closer look at what all are the components of a block. So whenever we talk about a blockchain, what is actually a block and what it consists of? Now there are four major components. Each block contains a previous hash. Data is nothing but the aggregation of the transactions which are aggregated in the block, a nuance value, and the hash of the block itself. Now, what is previous hash? Previous hash is the attribute which is connecting a block to its previous block. So the previous hash attribute consists of the hash value of its previous block. Data, it consists the details of the sender's address, the receiver's address, and the transaction amount. So basically, there could be multiple transactions amongst multiple senders and receivers. So each block will consist n number of transactions, and each transaction will have a sender's address, a receiver address, and a transaction amount. Nonce. So basically the Bitcoin uses a proof of work algorithm, and in order to execute the algorithm, nonce is a random value used to vary the output of the hash value. So proof of work is the process of transaction verification done in blockchain. Hash is like a digital fingerprint. It is the fingerprint of the current block. Now, where it takes an input value of the previous hash, the data, and the nonce, and produces an output value of fixed length. So Bitcoin network uses SHA-256 hashing algorithm to generate a 256-bit length hash. And this is the output. It looks something like a hexadecimal value. Now, what are the features of blockchain? A blockchain is a decentralized public distributed ledger that is used to record transaction across many computers. So this is a sample transaction which you are seeing. These are a set of three transactions: A transferring money to B, B to C, and C to B. A distributed ledger is a database that is shared among all the users who are part of the blockchain network. The transactions are accessed and verified by users associated to the Bitcoin network, thereby making it less prone to cyber attack. It is actually enclosed within all the participants who are part of the network. Now let's take an example where these Bitcoin users are transferring money. So here we have example like Bella is trying to transfer money to John, John is trying to transfer money to Elsa, and Elsa is trying to transfer money to Jack. So these are the three transactions which are to be initiated. Now suppose these transactions were being happening on a central ledger and it gets corrupted. So there is a chance of the data getting tampered. To solve this problem, a public distributed ledger plays a vital role. Now it ensures that users part of this cycle have a copy of the transaction details. Each user will have a copy of each transaction. Bella, John, Elsa, Jack, they all have the same ledger, and this is what is called as distributed ledger. Everyone is having the same copy. Now in case one of the users like Elsa misplaces her transaction detail, she can easily be corrected by the other participants because they have the golden copy, the correct copy. Or if either of them attempts to alter the record, the alternate transaction copies with the other users will negate the alteration because they will see that amongst all the participants only one participant is having a different copy. They will negate the copy of the user and they will rectify it. Encryption. Blockchain eliminates unauthorized access by using cryptographic algorithm SHA-256 to ensure that the blocks are kept secure. So SHA-256 is the cryptographic algorithm which is used. Each user in the blockchain has their own keys. So any user which onboards a typical blockchain network is always provided with two sets of keys. One is private, one is public. Private key is known only to the sender. Also, it is used to confirm if the origin of the transaction is legitimate. Public key, it is also used to uniquely identify the user, but it is shared by the sender with every transaction it floats on the blockchain network, and we will see how. Now let's take a look at a typical transaction verification process. Suppose a sender wants to send a message. He will pass the message through the hash function and generate a hash value of the message. Now, after the hash value is being created, it is passed through a signature algorithm, and with the private key, a digitally signed document is created. Now, the transaction message, original message, the digitally signed document, and the public key are transmitted to the receiver. Now, at the receiver end, the transaction message is passed through a hash function to get a hash value, and that hash value is compared with the hash value obtained by passing the digital signature and public key through a verification function. And then both the values are compared. Now let's see how the hash function works. The hash function creates a unique digital fingerprint of data. You pass the message to the hashing function and it generates a hash value. This hash value is called a digital print. It has a very unique property. Any hashing function is a one-way function. It cannot be reversed. You cannot decode the original value from the hashed value. It is a one-way encryption. So here are some examples. Whatever be the size of the input data, the hash value is always of 256-bit length. And we will take a look at the demo at the end of this session where I'll show you how to generate a hash value using SHA-256. Now let's consider an example of Gmail using hashing algorithm. Whenever you are entering the username and password, that password is never directly persisted in any of the Gmail's database. It is persisted using hashing function. So once you have created your password and again once you log in, your password is again passed to the hashing function and compared with the hash value persisted in the database. And once both these hash value matches, then only you are allowed to log in. So every time you log into Gmail, your password is hashed into a value and compared against the one stored in the database. The hash value is matched with the one in database and then the inbox is displayed on your screen. Now let's take a look of what is the proof of work algorithm. Proof of work is a method to validate transactions in a blockchain network by solving a complex mathematical puzzle, and this whole process is called mining. Finding the nonce value is the mathematical puzzle that users or miners need to solve in the Bitcoin network. So it takes huge amount of computational power and resources of the miner in order to find out that nonce value. Users trying to solve the puzzle are called miners. The puzzle is solved by determining a nonce that generates a hash value and results an output lesser than a target. So in any proof of work algorithm, there is always a target which is predefined for a block. the miner has to use the nonce in order to generate a hash which has to be less than the target. Miners verify transactions within a block and adds the block to the blockchain when they have confirmed and verified the transaction. With proof of work, miners compete against each other to solve the mathematical puzzle. The first miner who solves the puzzle is rewarded. And when a block is solved, the transactions contained in a block are also considered valid, and the bitcoins associated with the transactions then get deducted from the originator or the sender and moves to the receiver. Now let's see how proof of work works. So let's take a look at the block and its components. The previous block hash, it stores the hash value of the previous block of the blockchain. Data, it contains the list of all the transactions which have been aggregated in the block. Nonce is the random value which is used to generate a hash value less than the target, and hash is the digital signature of the block itself. The hash is generated using a hashing function called SHA-256. Now, using the nonce, when the hash is generated, if its output is less than the target, then the puzzle is deemed to be solved. The block is considered to be validated. If not, then the miner increments the nonce by value 1 and then again rehashes, generate a hash and goes through the cyclic process till the time it is not able to generate a hash less than the target. In blockchain, the target is adjusted every 2016 blocks, which is approximately every 14 days. The average time of block formation is 10 minutes. And the difficulty target of the puzzle increases or decreases depending on the time it takes to mine the blocks. So it is the inbuilt network which is generating the target for the puzzle to get solved, and it fluctuates the difficulty based on the time it takes to mine the block. Proof of work is hard to produce but very easy for miners to verify. So point to be noted here is, once the block is hashed, the remaining miners are supposed to validate the work which one miner has done, but they are not required to find the nonce again. So basically, the miner who's supposed to earn the Bitcoin has done the hard work, but the others miners on the network just have to verify his validation. In blockchain, when miners use their resources, time, money, electricity, etc., to validate a new transaction and record them on the public ledger, they are given a reward. Now that reward is in Bitcoins itself, which as of today stands at 12.5 Bitcoins. And to add, there is no other way that the Bitcoins can be generated in a Bitcoin network. It is only through mining. Now, the Bitcoin network internally halves the reward after every 21k blocks, which is approximately every 4 years. So now subsequently, whenever the time period will end, the mining reward will get reduced to 6.25 BTC. Now let's take a look at a demo. Now, as I said, this is a demo to showcase how to generate a SHA-256 hash using an input value. So whatever input I have, the hash which is generated, it is of 256 bytes. Even if I add a new value, it will again only generate a 256 bit length hash. Now let's take a look at a typical blockchain structure. We have a block over here which has one transaction added to it. Now this is orange in color because it has not been mined, and I can only add a subsequent block to it once it is mined. Now as this is the first block in this particular blockchain, the previous hash value of this block is all zeros and it is called as a genesis block. Now as I have mined this block, the hash, which is the digital signature of this block itself, is being generated, and I can now add a block. Primary thing which to be noted over here is that the previous hash value of this new block is the hash value of the previous block. It has two transactions aggregated in it, and I can again mine it, and now the hash of this block has been generated. So this highlights the typical data structure of a blockchain and how blocks are linking themselves to each other. Now let's take a look of a typical transaction which happens over a blockchain. Now I want to send money from wallet 1 to wallet 2 and I want to send $1. There is a transaction fee of $0.1 associated with this transaction. Now as I have initiated the transaction, wallet 1 has been deducted as $1.1 and it is a pending transaction. This transaction is waiting to be mined. So I can choose any of the miners to do this transaction. The pending transaction is done. And now block 2, if you see, has been added. The previous hash value of this block is 00A9 is the hash value of block 1. Another thing to be noted, the value of the amount in wallet 2 has also got incremented by $1. Again, we can try another transaction, transferring $1 again from wallet 1 to wallet 3, and say from wallet 2 to wallet 3 I have done a transaction, it is pending, it can be mined, and block 3 has got added. Now, what are the key takeaways today? We learned what are the current issues in the banking system and how Bitcoin solve them, what is blockchain, features of blockchain, and a demo of the features which we have seen.